Hello all, let's start chapter 8. In chapter 8, we will cover the graph of trigonometric functions. Of course, we will start first with graph of sine and cosine. My lectures here in this video may look a little bit different than your book, what they did in your book, but follow these lectures. As you see, I will do a lecture for 8.1, 8.2, and 8.3 as a one lecture because it's all about the graph of sine and cosine. In your books, immediately they jumped from graph of sine to shifting transformation. That's why here I'll go step by step. I'll start with simple graph of sine and cosine. We will explain what is the shape, what is the domain, what is the range, key points, x-intercept, some of those stuff that helps graphing a lot, and an easy method how to graph. Then of course we start with transformation. In your book they immediately jumped to the phase change, but what I do in these lectures, I will start with vertical shift. I will start with the vertical stretch or compress. Then we jump slowly, we go and add the phase shift or horizontal shift, which we call it in trigonometry phase shift. Anyway, let's start with graph of sine and cosine. I will try here first to explain for you what is the shape of y or f of x, which way you write in your book. They're writing y. I'm also using y equal sine x. Or to put it in a better way, even that a little bit closer to your book, I can write y equal a sine x. We want to graph first this function. It means a basic graph for sine, because soon you will see everything will change when we add phase shift and vertical shift and a stretch, but the basic graph of sine. Excuse me. Let me explain here the coordinate system for you. As you see, I have the x-axis and I have the y-axis. Remember, your x is always, x is our input, correct? And y is our output. Some students, when they graph and see here x and y, immediately, because I explained to you in a unit circle that you have x comma y, and x is always cosine, y is always sine, they think this way. Remember, here when we are graphing, your x-axis is input. Input in a unit circle means this angle, correct? This angle or this arc length, because in a unit circle our arc length and angle is equal, correct? That's why when you plug in, you see like pi over 2 here. I plug in, actually I plug in this angle, correct? Pi over 2. Then I have pi, then I have 3 pi over 2, then I have 2 pi, which is a full round, correct? Now, I will explain why I choose these numbers and why not the other numbers. Everything comes when I explain the graph of sine. Just right now, remember, your input is all these angles that you see in a unit circle, and it works always when you use radian. It means when you use unit circle, correct? Zero angle, which is here, this is you are always 0, correct? Then halfway, pi over 2, then half around, which is your pi, then 3 pi over 2, then what? 2 pi, correct? Because here you have 0, and also I have to show here 2 pi in this unit circle, a full round. Now, what happens and what we want to explain here? What we want to explain here, I will start with this. First, I want to see what is the domain of the sine? I want to answer this. What is the range? Correct? Is this function is odd or even? We don't know yet, but based on the shape, we will check. Correct? The period, which is period means one cycle that the graph completes. I will explain what is the period for the sine. The x-intercept for the sine and key points, which we will explain soon. Now, let's start with graphing. Look into your unit circle and bring those numbers to the system. For 0, when you are looking for the sine of 0, correct? It means when you have a function y equals sine of 0. What is the sine of 0? You see, this is your 0 angle, and the sine of 0 is always what? Always 1, correct? It means when your angle is 0, if I mark this place as a 1, the value of sine is what? 0, not 1. I read wrong. The sine of 0 is 0, correct? It means you have this point. For pi over 2, which is here, this angle, pi over 2, from here to here, for pi over 2, the sine of pi over 2 is 1. It means when you plug in, when your input is pi over 2, the output will be 1. Let's mark this point. Correct? When you move to pi, let me use green. It means this angle, all the way, halfway. What is the sine of pi? The sine of pi is again what? 0. And when you go to 3 pi over 2 here, what is the sine of 3 pi over 2? The sine of 3 pi over 2 is negative 1. If I mark here as a negative 1, sine of 3 pi over 2 is negative 1. It means this point. And finally, when you do a full round like this, you turn all the way and come back here. It's a positive angle, correct? It means 2 pi. What is the sine of 2 pi? The sine of 2 pi is again what? 0. Now, if I want to graph this, I can even, you can say you can plug in pi over 6, which will be somewhere here. This is pi over 6, and you will see the graph will be 1/2. I don't want to show all those points because the graph will look too busy. Even with this, you know where the graph starts. The graph starts from 0, 0, goes up to 1, turns around, comes to pi, another x-intercept, goes down to 3 pi over 2, which is negative 1, and turns and comes up to 2 pi, correct? And of course, it continues to infinity this side, and it continues here to infinity. It means the graph of sine is, as you see, it's a smooth curve. It's a smooth curve, and the domain is from negative infinity to positive infinity. The graph of sine, remember, take these notes. The graph of sine is a periodic graph. It means in every 2 pi, the graph repeats. It again goes here and comes down like this, goes up, come down. It repeats again, also in this side. It repeats again like this, correct? The graph of sine is repeating, correct, in every 2 pi. Now, look at the range. What is the range of sine? As you see, it starts from negative infinity and the graph goes up to, not negative infinity, sorry, negative 1 and goes up to positive 1. Then the range starts from negative 1 and goes to what? To 1. What is the type of this function? Is this odd and even? How you know? Look at this part of the graph. If you look this part of the graph, you see the graph of sine is symmetric about origin. If it's symmetric about origin, it means the graph is odd. If you don't remember my lectures from algebra, an odd function is when f of negative x becomes equal negative f of x. Correct? Remember this, because soon I will tell you this. When you have sine of, let's say, negative 3x, I will write immediately this one as a negative sine of 3x. I asked the other day in one of the other classes, and I was sub in one of the colleges, not our college. I said, why this one is equals to negative sign? They said, oh, we factor actually the negative. Please, we cannot factor the negative. The reason that we are writing sine of negative 3x equal to negative sine of 3x because the function of sine is an odd function. And that this is the relation for the odd functions. Correct? Next, period. As you see, your graph of the sine completes in 2 pi. Then the period for the function of sine, and also soon I will talk about cosine, is 2 pi. Please remember it's only for sine and cosine. The period for sine and cosine is 2 pi. It's not always 2 pi. For tangent and cotangent, it changes to pi, not 2 pi. Correct? But for sine, cosine, maybe secant and cosecant, the period is 2 pi. Now, x-intercept. I will put some notes for x-intercept, okay? Please write these notes. These notes actually helping you how to graph. Sine crosses the x-axis at, let's see where it crosses at. Look at the graph. Here, here, and here. As you see, in 3 points, sine crosses the x-axis, which is the beginning of the graph, the middle of the graph, and the end of the graph. Beginning and end, two sides, we just call it end, right? Sine crosses the x-axis at ends and where? Center. It looks really easy here for you. Why I should make this note? Believe me, when you graph, this statement lets you to easily find the x-intercepts and graph sine. If you don't remember this sentence, you may mark, or every time you have to run to unit circle or calculator and see where these are the zeros. But remember this, sine crosses the x-axis at end and center, correct? Of center of what? Of the period. And peaks. I call it peaks. It means your maximum and minimum. We call it peaks. Look, I have a peak here at 1, and I have a peak here at -1. These are the peaks. It means the max and min. In general, I call it peaks. And peaks at quarters. Of period. Quarters, you see, from 0 to pi over 2, it's 1/4, correct? It's 1/4 of the period. That's why we call it quarters. From pi to 3 pi over 2, it's another quarter, correct? Then always the peaks for your graph of sine is at quarters. You may ask me why I am not naming like pi over 2 and 3 pi over 2. Yes, for the basic graph, I can say the graph peaks at pi over 2 and 3 pi over 2. But believe me, when we start with transformation, these numbers are changing. That's why I'm telling you at quarters, because your period is changing based on the shifting, right? And that's why I put a general sentence. Sine crosses the x-axis at the ends and center of the period and peaks at quarters of the period. Correct? Now, so some key points for the graph of sine. Correct? Key points. When I'm talking about key points, please don't think that these key points is always for any function. I told you when we do shifting, these key points are changing, but still we are using these key points, and it makes it really easy for us how to change the key points. Correct? The key points is 0, 0, which was the start of the graph. You see, one of the key points is at 0, 0. The other key point is pi over 2 and 1. Correct? We call it key points. And usually, when I'm graphing, after I find my zeros, I will use this key point and the other one, which is 3 pi over 2, which gives me -1. We call actually these two the key points. Because the other ones we call it zeros, right? These 2 points are the key points for the graph of what? Sine. Correct? Now, I'll do an easy example here. An easy example for you and show you how you can graph a sine function. Correct? But before that, let me explain a few more things for you. One more thing also. You see, your general form is y equal a sine x. Sometimes we use this parentheses, sometimes we don't use it. It's okay. A is actually that peak, which here we call it amplitude, correct? Your A is actually your amplitude. That means how much the graph goes up and down. We call that one amplitude, which I called it here peaks, correct? But that's always your amplitude, correct? X is, since we start trigonometry, x is our angle, which we call it also argument, correct? This is also as your argument. This x can change, correct? This is your argument. But A is always your amplitude. And remember, amplitude is actually your vertical stretch or compress. Correct? A, if you remember transformation, the number that comes at the beginning, that's always our vertical stretch, or we call it horizontal stretch, or we call it vertical stretch or compress. Correct? And I will show you in next 2 examples how that A affects the graph of sine. Let's do a few examples here. 2 examples and see what we can do after that. Graph. Let's graph y equal 1/2 sine x. Correct? To graph this, few things that I need here. period. What is my period? Correct? Your period for normal graph, I don't want to give you right now here a formula. But soon I will give you a formula for period. For a normal graph of sine x, your period is 2 pi. Correct? Let's graph slowly. Please focus here, how I find those points, correct? The 4 points that I need. 1 point, 2 point, 3, and 4 point. Here I will mark it as a 2 pi. How you find the next points? Just look at here. It's important because soon your period will change from 2 pi because we will do shifting, and you shouldn't say, okay, now what's that number? When you find these 4 numbers, first divide your 2 pi by 2. Find the middle or the center. 2 pi divided by 2 gives you pi, which is your center, correct? You see, in the actual, when I explained sine, here was pi, but how you find, you divide by 2. You find actually halfway. Now, if you divide pi, you can find by 2, you can find the first quarter, correct? Pi divided by 2 gives you pi over 2, which is this point. Now, how to find this point? Some people, they use average. Some professors, they add pi with 2 pi, then divide by 2. Or I can tell you, always to find the third quarter, add these two numbers. It means pi over 2 plus pi. To add these two, you need a common denominator. You have to multiply this one by 2. Pi over 2 plus 2 pi over 2. Pi over 2 plus 2 pi over 2 gives you 3 pi over 2, which is this number. Correct? 3 pi over 2 here. After you did this, mark your zeros based on what I told you. The sine has a 0 at the ends. It means at 0 and 2 pi, and also center. Correct? We are done with that. Now, look at your amplitude. Your amplitude is half. If here is 1, here will be half. And here will be negative 1/2. And here will be negative 1. Correct? Now, the graph always starts from 0. At pi over 2, it becomes half because of the amplitude. Then it goes back to 0 to pi. At 3 pi over 2, it becomes negative half, which is here. Then it goes up to where? To 2 pi. If you want to compare it with actual graph of sine, you see it starts at 0. If I use dash line, goes to 1, then it comes to pi, goes to negative 1, which is this point, and it goes up. You see here, you actually see a vertical compress, because you can easily compare it with actual standard graph of sine. The amplitude is compressed to 1/2. Correct? Let's do one more example. Then I'll stop the first point of the lecture, and then I will talk about cosine in the next lecture. Y equal, let's say, this time 3 sine x. Let's see what's happening. Again, I'm graphing. Later, soon, I will give you a formula for the period, but right now, don't worry, because we are just graphing with sine x. We don't have here 3x or 4x. I'm not talking about that period yet. I know the period is 2 pi. Okay, here I'll mark it as a 2 pi. Halfway, I know I will mark it pi. First quarter, pi over 2. and here 3 pi over what? 2. Mark always zeros first at the ends and at the center. The other day I was graphing for a class. I said, how you find your zeros? They were thinking like, oh, we look at the table, we look at it. I said, no, 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 no. Just remember that sentence. Sine always at the ends and centers, you have your zeros or x-intercept, correct? Now, look at your amplitude. Your amplitude is 3. 1, 2, 3. I'll mark here 3. 1, 2, 3. I'll mark here -3. Okay, these are, let me show you the key points, how it goes. What was the real key points? You had at pi over 2 and 1, correct? And you had 3 pi over 2, the key points, and -1. Look how these key points are changing. What you do, multiply your output with your amplitude like this. Multiply this number here and here, only the output. It gives you your new key points, which is pi over 2, and 1 times 3 gives you 3, and -1 times 3 gives you -3. It means 3 pi over 2 and -3. Correct? This is how you find your key point. These were the actual key points. Remember I told you, 2 key points. 2 key points means the peaks. In a standard sine, it's always like this, pi over 2 and 1, 3 pi over 2 and -1. But when your amplitude is changing, you just multiply your amplitude, which was your A, correct, to where? To your output. And it gives you the new key points. It means at pi over 2, the graph becomes 3. At 3 pi over 2, the graph becomes what? -3. Now, easily you can graph. Just connect these points with a smooth curve. That's the graph of y equal 3 sine x. And if you see the actual sine x, if I graph it with the red, this is the actual sine x because the amplitude there is 1, correct? And you see here you have a vertical stretch. Correct? I will stop the lecture. In part 2, I will cover cosine. In part 3, we will start with transformation. See you all in part 2 of this lecture.